current, distribution of current in resistances, So basically very simple, whenever there is some current I is coming and it is dividing into two branches, one is carrying total resistance of R1 and second branch is carrying total resistance of R2, then what is the current, what is the amount of current going to R1 and what is the amount of going current to R2. So this is what we need to, this is called as distribution of current. Of course distribution will be only when the resistances are connected in parallel. If they are in series, they would have same current. But in this case, I is inversely proportional to R, as we have done for the charges. Here also, if they are inversely proportional to charge, then the current will depend on R2, I1 will depend on R2. So I1 will be equal to total current upon total resistance, R1 plus R2, into because it is inversely proportional, it will depend on the second resistance R2. It is inversely proportional. Similarly, you can rewrite I2 as total current upon total resistance R1 plus R2 times, when I am writing I2 current, it will, you have to multiply it by I1. Very simple. For example, suppose in some circuit, they say, let us say this is 6 ohm, this is 3 ohm, let us say 9 ampere of current is flowing in it. So you can clearly see this 9 ampere will come here and will distribute in current I1 and I2. So we can write I1, I2 directly using the formula. How do we write I1? I1 is the total current, this 9 ampere will be total current upon total resistance. So this will be, total current is 9 upon total resistance will be 6 plus 3 into, if I am writing current through 6 ohm, I will multiply by 3. So this will be 3 ampere directly. Similarly for this one, because the total current is 9 ampere, so I can directly write 9 minus 3 or just 6 ampere, or you can also apply the formula. So this is how we can determine the current distribution among two resistances. Now let us talk about distribution of voltages. Distribution of voltage. So basically, whenever two resistances are combined in series and they are connected to a battery of, let us say, voltage V. So we would like to know what is the potential difference across this one V1, it is a difference, and what is the potential difference across this thing V2, R1 and R2. So similar to voltage, we can also determine the potential differences. Remember, it is not potential, it is the potential difference, my dear. It is potential between A and B, and this is B and C. So basically VA minus VB, its a difference is V1, and VB minus VC is basically V2. And you can write potential difference as directly, because potential is directly proportional to resistance, remember, because current is same. So as large value is the value of resistance, more will be the potential. So direct result will be V1 will be equal to total voltage upon total resistance R1 plus R2 times R1, and V2 will be total voltage times R1 plus R2 times R2. Remember, these are potential differences, is not absolute potentials. Okay. For example, you can solve it directly. For example, some 10 volt battery is connected against 3 ohm and 6 ohm, and you would like to know, sir, what is the potential drop, what is the reading of voltmeter V1. So very simple, this is 10 volts, so V1 will be equal to, you can clearly see, V1 is equal to total voltage is 10 upon total resistance will be 3 plus 6 into this time multiply by 3. So, this will be, when you solve, this will become 30 by 9, that is 10 by 3 volt. So, reading of this will be 10 by 3 volt and reading of the other one will be 20 by 3 volt. So, this is how we write the distribution. Now, let us go to the next point, how to write absolute potential of points. Absolute potentials of nodes. This is again a very important concept. We can directly write the absolute potential of nodes. Suppose if I know the potential of 2 points across the resistances. Suppose this is V1 and this is V2, this is R1 and this is R2, and we want to write what is the potential of this point. What is potential? This is not difference, my dear, this is potential of this point. It means if this is point A, this is point B and this is point C, then potential of A is V1, potential of B is V2, and we would like to know what is potential of C. So, the direct formula is there for to write this V is V will be equal to, remember, V1 R2 plus V2 R1 upon R1 plus R2. This formula basically is derived using Kirchhoff's current law. We assume that the total current, incoming current will be the outgoing current, and we write the current in terms of V minus V1 by R1 is equal to V minus V2 by R2. By equating them, we get the expression of voltage V as V1 R2 minus V2 R1 upon R1 plus R2. So, you can directly use this formula to write the potential of this point in terms of V1 and V2. For example, of course, you can also write, so suppose if there are 3 branches connected, suppose if there are some node where 3 branches are connected, this is R1, this is R2, this is R3. Let us say this is R1 is connected to V1, R2 is connected to V2, R3 is connected to V3, then you can write the potential of this point of this node directly. How do we write? So, basic formula is this V will be equal to V1 by R1 plus V2 by R2 plus V3 by R3 upon 1 by R1 plus 1 by R2 plus 1 by R3. So, sometimes these standard results are very helpful to solve the problems. The only thing here is to determine V1 and V2. We have to determine V and V2 to solve the questions. So, for example, suppose some ideal battery E is connected, across, let us say this is R and this is R and this is R1 and this is R2, and let us say this point is A and this point is B. So, what they are asking, find the potential difference VA minus VB. This is what we need to find. So, for this thing, my dear students, you have to write the potential of A and then potential of B and take their difference. So, how will you solve it? We basically we start from assuming 0 voltage to the lower terminal of the battery. We assume that the lower terminal of battery is 0 volt. So, clearly the higher terminal will become E and it will remain E until unless there is resistance R. So, basically these 2 points will reach at E, this is also E, and this 0 will reach here 0 volt, 0 volt. So, if you can see clearly, these two resistances are connected across V1 is E and V2 is 0. So, we can write the potential of A directly. Although in this case, because both resistances are same, it is very clearly that you can say VA is nothing but half E by 2 directly. But to write VB, you have to apply the formula. VB is E1 R2 plus E2 R1 upon R1 plus R2. So, in this case E1, the first one is E and second one V2 is 0. So, it will be E times R2 plus 0 times R1 upon R1 plus R2 is equal to VB. So from here we can directly calculate VA minus VB will be E by 2 minus ER2 upon R1 plus R2 will be equal to V potential difference of A and B. So by just taking E common, it will become E by 2 common, it will become R1 plus R2 minus 2R2 upon R1 plus R2. So this will become E by 2 times R1 minus R2 upon R1 plus times R2 will be equal to the potential difference across A and B points. So this is how we can calculate potential differences, or in general potential difference between any 2 points. This is also called as sometimes nodal analysis. So I think this concept is clear to you now. Now final thing about KCL and KVL. Kirchhoff current laws and Kirchhoff basic theorems. So Kirchhoff current law KCL, it states that sum of all the currents through any node will be 0, that is I1 plus I2 plus I3 through all the nodes, total incoming current equal to total outgoing current. This is the simple standard law of KCL, which is based upon the conservation of charge principle. Conservation of charge. So total incoming charge should be equal to total outgoing charge, or net current through any node will be 0. For example, if suppose there are something like this, these are 2 nodes, this is 2 ampere is coming like this, 1 ampere is coming like this, and we need to find I1 and I2, and suppose 4 ampere is going like this. So you have to identify node and apply the KCL at each node. So here you can see there are 2 nodes, one node is this and one node is this. So let's say this is node A, that is node B. So what is net current at node A? So we will take incoming current as positive, outgoing current as negative. So you can see the net incoming current is plus 2 and plus 1 minus I1, and this net should be 0. So you can see I1 should be equal to 3 ampere directly. Similarly at node B you can see net incoming current, there is no incoming current, all currents are outgoing. So I2 is also negative, minus 4 minus 1 is equal to 0. So basically I2 will be equal to minus 5 ampere. So this is basically Kirchhoff's current law, very simple. Now let us go to the Kirchhoff voltage law. KVL, Kirchhoff's voltage law. So basically it states algebraic sum of potential differences in any closed loop, in any closed loop is 0. So that is V1 plus minus V2 plus minus V3 should be equal to 0 for any closed loop. So this is basically based upon conservation of energy, conservative nature of electric field, So basically, as I told you, potential is the work done by electric field when the charge moves in a conductor. So if the charge move in a loop inside the conductor, many electric fields do the work, but because electric field is a conservative nature, so in any closed path the work done by conservative force is always 0. So basically you have to, the important thing in this to learn is how to identify these plus minus charges. So the idea is very simple. Just think of the work done. Suppose this is a battery of EMF E and you are moving from A to B. So when an electron, when you are going from A to B, you can clearly see the energy when the electron comes out of this, when the electron comes out of this battery, the battery will transfer energy if it is coming out from the positive terminal. Okay, so don't think that when it comes to negative terminal potential energy decreases. No, when it crosses the battery, then see, because just by touching the negative terminal energy won't change. When you go inside the battery, when the electron goes inside the battery, then battery does the work, and when it comes out of the positive terminal, then the energy is increased. So how much energy is increased? VB, the energy at B will be of course greater than energy at A. How much greater? VB will be equal to VA plus work done by this cell, that is E. So always remember, whenever you go from lower terminal to higher terminal, become an electron, visualize as electron. So when you pass through the battery, if you come out of the positive terminal, add. If you come out of the negative terminal, subtract. You can also rewrite it as VA will be equal to VB minus E. It means when you are going from B to A, subtract. So basically this is low. When you go from low to high, add. When you go from high to low, subtract. Simple. So this is how we write polarity potential differences for the batteries, irrespective of the direction of current. Remember, this is irrespective of current. Okay. Now second thing is for resistances. Now for resistances, my dear students, the direction of current becomes important because resistance is symmetric about both ends. How we decide which one is higher and which one is lower? So for that we need to see the direction of current. So for example, in this case, suppose if I am saying the current is flowing like this, if the current is flowing like this, then this resistance will take out the energy of IR and current always goes from high to low. So this is high and this is low. Let us say this is point B. Let us say this is point B and this is point A. So current, the direction of current will decide high and low for resistance, not for battery. So for resistance you have to see in which direction the current is flowing. So if this current is flowing from right to, from left to right, you can see this must be high, that must be low. Now it's easy. What is the difference between them? IR. So if I write VB is greater than VA. How much greater? VB is equal to VA plus I times R. That's all. Similarly, if you rewrite it, it becomes VA will be equal to VB minus IR. So you just need to decide which one is higher. So whenever you go from B to A, subtract. If you move along the current, subtract. If you move opposite to the current, add. For example, suppose the 2 ampere current is flowing like this. This is 10 volt battery, this is 3 ohm, this is 1 ohm. This is point A and this is point B, and they are asking us what is potential difference VA minus VB. They are asking potential difference. So basically what we need to do, we have to start from A and reach B. We have to start from A and reach B. How will we do that? Very simple. So potential at A, when a charge starts moving from A, when we go from A, we will become charge. So we are moving in the direction of current. So if you are moving in the direction of current, you can say the current will be same everywhere. So this is the potential difference here, IR will be 2 into 6 volt. This is high and this is low. Here also you can see when you enter here battery, you can see this is high, this is low. Similarly for this resistance, this is high, this is low. So to reach from A to B, you see many highs and lows, but to decide we have to add or subtract, we have to see how when we cross. So when we cross this battery from A, we are going from A, so we are already at high, you can see you are already at high. So when you go from A to, when you cross this resistance, you are reaching to a new low, so your potential will become minus 6. Now from this, when you cross this battery, you are again reaching a new low, so that is minus 10. Then again when you cross this to the other resistance, you are again going from high to low, so this is minus, current is same, that is 3 volt I into R, so minus 3, and finally you reach at point B. So basically all of them will decrease the energy of electron. This one battery will also decrease and this one will also decrease. So you can see VA minus VB will be equal 19 volt. Very standard result, my dear. So this is Kirchhoff's voltage law. Of course, you might have done some questions in class 12th by making loops into circuits and by solving them, but that approach is not recommended in NEET, because you already know that it takes very much time to solve two equations, and forming those two equations there is a lot of probability, lot of scope of error. So we ignore making KVL uses, we ignore the equation involving KVL to solve the current and voltage problems. Rather we use standard results, we combine the batteries and then we determine the current and voltage in different circuits. So let us solve few problems so that you can understand better what I am trying to say, what I am trying to convey in this circuit solving episode.